So one of the most important things you'll understand about this assignment is that it's actually, several different problems. You got to find the discriminant, you got to put the vertex form, you got to interpret that as a vertex from chapter 2, adding in the axis of symmetry, you got to find the x and y intercepts, and then you have to graph. So pace yourself. And I got to be honest with you, if you're really good at solving, maybe solve as many as you can, but you're going to run into the problem when you get down to number 3 that it doesn't factor. And that's sort of what this process in here is for. So let me focus on the algebra on number 1, just so you understand the process when everything is, fairly straightforward. The discriminant is b squared minus 4ac, which you've done before. In this case, it comes out to 4, which tells you there's 2 real answers and 0 imaginary. By the way, there can ever only be 2 real, 2 imaginary, or 1 real. It is impossible to have a mix of 2 and 1 or 1 and 2 in quadratics. Later in the next chapter, you'll see that there is a way. But in this chapter, 2 here, 2 here, or 1 there. By the way, you can never have 1 imaginary answer ever in your life, no matter what chapter. So this tells me also that this is going to factor. So if you wanted to factor it, solve it, and get the x-intercepts, you can. To put this in the correct vertex method, you notice I gave you some boxes here. The biggest problem I'm seeing students do is they're not actually showing what C is. That's really important because C not only gives you the 4 that you add to both sides, but it also is going to give you the factorization. Please notice that this right here and this right here are the same. They always are. So once you have that, you subtract 9 on the other side to put it in chapter 2 way, and then you have opposite HK. The axis of symmetry is always the first part of the vertex. Part D, the y-intercept part, is to actually just plug 0 in. And when you plug 0 in, you're just doing chapter 1. You just get -5. You're always just going to get C in standard form, by the way. And yeah, you could actually plug 0 in here. You would get -5. It'd just be more complicated, right? Because you get 4 minus 9, which is -5. So you get it in either place, but it's easier in standard form. And then you're going to graph this using your method from chapter 2, starting at this axis at 2, -9. I had to go by 2, so you're going to have to change the axis sometimes. So remember, -2 is opposite h, so the vertex is 2, -9. So I went to 2, -9. I went 1, 1, 1, 1, 2, 4, and 2, 4. That gave me my y-intercept. Now I went ahead and graphed my x-intercepts, and those would actually come from doing 3, 9, 3, 9. Sorry, -3, 9, and 3, 9. Notice I labeled everything. So the next problem is very similar, but it has 0 for C. So when you plug it in, it cancels this whole part, giving you 9, telling you it's factorable, specifically factorable using GCF method. And some kids they have a lot of trouble with this because it has fractions, but you've got to write down what C is. If you don't write down what C is, no wonder you're having trouble. So you're supposed to do B over 2 squared. Okay, so you take half of whatever B is, and you don't turn it into a decimal. So that's 3 halves, and you square it, you get 9/4. You add 9/4 to both sides. And then this is the part that I think is so important. This is where students are getting stuck. This is my answer right here. They're the same. So not writing down C and how you get it is where students are getting stuck. Okay, so you add 9/4 to both sides, and then you can get H and K if you understand opposite H and opposite K, but we don't do that in high school typically. So we move the K over, and then we have opposite H, comma, K. Now, some students will say, how am I going to graph that? Okay, so I come to my graph. I went by ones. I went to 1.5 and -2.25, and I literally went 1, 1, 1, 1. Then I went 2, 4, 2, 4. And then I graphed my parabola, and it went right through my x-intercepts that I hadn't even found yet. And then I went over and found my x-intercepts by factoring out an x, because that's the GCF, giving me both my x-intercepts. And please notice this. If this is ever 0, 0, this will also be 0, 0. Okay? So then we get to number 3, and you start to see why factoring, it just doesn't always work. So first of all, the discriminant's negative, giving you 2 imaginary. When this is negative, it doesn't factor. So it's not factorable. So then we completed the square. Again, I actually wrote down what C was. So B over 2A, right? And B over 2A is going to come out to, in this case, -3. So we have b over 2a, which would be -6/2, which is -3 squared is 9. Notice the factorization, -3 and -3 squared, right? I think that's the part that some students, they're rushing through their work and they're not grasping the shortcutness of that right there. All right, so I added 9 to both sides, but I had a 10 that I had to move over. So -10 plus 9 is -1. And then I've got to move the 1 back over, and there's my vertex form, opposite HK. I can graph it, right? 3, 1, 1, 1, 2, 4, 1, 1, 2, 4. You can see there's no x-intercepts. So why did I shade above? On this particular problem, I did sneak in the greater than sign, which means shade above and make it dotted. So now let's talk about the whole solving, right? So when I solve this, if I solve it from 3.2, I subtract 1 and get the square root of a -1, which is I, and then I add 3, and I get answers. These are solutions, but they're not x-intercepts. So you've got to keep this in perspective of the assignment. This is the answer from 3.2, but this assignment is about graphing, and the graph has no x-intercepts. So for right here, when it says, what are the x-intercepts? I wrote none. That's the right answer, but there are solutions for another part of the test. All right, on the back, you have to worry about factoring out GCFs. There was a typo on this, so make sure that this is a 2, this is a -2, this is a 2, and this is a 2. And other than that, it's the same old deal. I did A, B, and C. You don't need to factor out a GCF to do the discriminant. I got 0, which is the first time I've ever seen one answer. But it does factor, so we'll get back to that. So I moved the 2 over. You can see right there, that should be a minus, right? So I guess I forgot to put the minus there as well. That should be a minus, all right? And so I factored out the 2 and got a 1. I showed what C is, so I factored out the 2 and got a 2. I showed what C is and got C to be 1, so I added to both sides. You can see that I have that 2 there to multiply. So -2 plus 2 is 0. Over here, you get 2x minus 1. I mean, if you want to write x minus 1 and x minus 1 down and then show that, that's fine. So my h is -1, my k is 0. Everything's nice to factor. Now, keep in mind what this means. It's important to see this too, right? So this 2 is telling you to stretch that to 2, right? And this 2 is also making the 4 become 8. So just remember that whole idea. That's straight out of chapter 2. All right, finding the y-intercept is always 0. You plug 0 in. It's very easy to find y-intercepts. And you can see it right there on the graph to confirm it. But to solve this, it's factorable. So why would you go through all this mess? I mean, you could, but you factor it. You take out a 2, you factor it, and you see why the discriminant is telling you there's only one answer. The reason the discriminant is telling you there's one answer is because I only have one factor. I mean, I know that I have one unique factor. I know that this is x minus 1 and x minus 1. It's really x minus 1 squared. Duh, it's right there. But when you set it equal to 0, you only get one answer. So if you wrote down that you had 2 answers, look at your graph. There's only one. It's right there, right? Your only x-intercept is this one right here at 1, 0. So that's called a double root. A double root is when the vertex rests on the x-axis. Anywhere on the x-axis, the y-axis does not matter unless you're talking about the y-intercept. But if my vertex rests on the x-axis, that's called a double root. All right, so I'm going to let you, try to work on the rest of them. I did do the completing the square part, and I'll post that on Canvas because I feel like that's the part that a lot of people need to see and work on. So I did that for number 5. I also did it for number 6, so you can see that. I hope this helps, and I hope you have a nice studying time. Please work. The test is coming up, and this assignment is like a little bit longer, but man, is it helpful in terms of understanding the majority of the chapter, honestly. All right, I hope it helps.